guys. All right. Okay, so this is the first problem. Okay, they give you this. This is a beam, by the way, and they give you the cross section. You know the neutral axis is going to be in the middle because of symmetry. Okay, so first they give you in the problem. They say the transverse shear, the maximum transverse shear, is equal to 50 MPa. Okay, and in order to solve this problem, they want to know what's the transverse shear in section A, B, and C in this beam. Okay, so in order to solve this problem, you know the transverse shear, tau, is equal to VQ over IT, right? Okay, so what we're missing from this problem is V. We have to solve for V first. They give you the maximum transverse shear, so you have to find the maximum shear force first. Okay, so let's find that. First, let's find I, because I is pretty easy to find. Q we need to draw a section, just the upper half. Remember, the maximum shear occurs at the neutral axis, so we're going to have to just draw the upper half of this beam. And T is just the thickness of this beam over here, which is 12 millimeters. Okay, so let's find the total moment of inertia, right? I'll break this up into sections. I'll call this section 1. This is 1, 2, 3, 4, and 5. Okay? So we have 5 sections, right? So the moment of inertia for 1, I1 is equal to 112. B in this case is 12. H in this case is just 30 plus 40 plus 50 plus 10 plus 30. Okay, so that totals to 130. All right, guys, be quiet. Okay. All right, so I1 is equal to 2.20 times 10 to the 6 millimeters to the 4th. Okay. So I1 is equal to, well, we don't have to convert it to meters yet. We'll do that at the end. Okay. So now let's find I2 and I3 and I4 and I5. Notice the neutral axis is here and it's symmetrical on both sides. Shut up, dude, shut up. Okay. Alright, so the moment of inertia for 4, 5, 2, and 3 are going to be the same because D is the same for each one. You need the parallel axis theorem. This is D2. This is D5. The distances are the same, and the areas of each section are the same, so you'll notice they're all going to be the same, the moment of inertia. So I2 is equal to I3 is equal to I4, which is equal to I5. Okay, so I2 is equal to 112. In this case, it's 40, okay?
Times 10.
40 times 10 cubed plus A is 40 times 10. And the distance is, this distance is 25. This is 25 millimeters plus half this distance, which is 10. So it's 30 millimeters. So D is 30 millimeters squared. Okay, so I2, which is equal to I3, I4, and I5, is equal to 3.63 times 10 to the 5th millimeters to the 4th. Okay, so we can get the total moment of inertia of this thing. So the total moment of inertia is just the sum of all the moment of inertia. So it's I1 plus I2 plus I3 plus I4 plus I5. So the total moment of inertia you get is 3.65 times 10 to the 6 millimeters to the 4th, okay? And in meters, we want to convert this into meters because when we find the shear force, we need everything in corresponding units. So I is equal to 3.65 times 10 to the negative 6 meters to the 4th, okay? So we got the total moment of inertia over here. Now we have to calculate Q. And we know they give you the maximum shear stress, transverse shear stress. So the Q we have to calculate is from the neutral axis, so it's this section over here. So this is the Q we're interested in, okay? So let's draw that. Okay, so we found I. We know T. T is going to be 12 in this case. So let's draw this. Okay, we have the neutral axis, right? Okay, and then we have this shape over here. Okay. All right, so we could break this up again into 3 pieces. Okay. So we're gonna have to find Q. This is box 1, this is 2, and this is 3. Okay? Doesn't really matter the numbering. So we're gonna have to find Q of this whole thing. Okay? So Q total is gonna be equal to Q1 plus Q2 plus Q3, right? Okay. So we're going to need the distances. They give you the distances in the original problem. So this distance over here is 25 millimeters. And the distance from the neutral axis to the center of 3 is 30. Yeah, 30 millimeters. And what is that? That's going to be y bar 3 in our case. Is equal to y bar 3. And y bar 2, of course, is the same value. This is y bar 2. And this is equal to 30 millimeters. Okay, and then they give you, so this distance over here is 10 millimeters. And then from here to here is 30 millimeters. And they give you the thickness of this member is 12 millimeters. Okay. All right, so we got everything we need. Oh, what's the y bar for this one? Okay, we have 25. 25 plus 10 is 35. So it's 65 divided by 2. So, let me erase this. So y bar 1 is 65 divided by 2. 32.5 exactly. So this is y bar 1, which is 32.5 millimeters. Okay. All right, so we got everything. Now we can find Q1, Q2, and Q3. We know Q1 is A1 y bar 1. So Q total is equal to A1 y bar 1 plus A2 y bar 2 plus A3 y bar 3. Okay? And so we could just fill this in. Q is equal to Q total is equal to A1 is equal to 12 multiplied by 25 plus that's 35, 65. Okay, times y bar 1, which is 32.5 plus A2. A2 and A3, well, Q2 and Q3 are the same. So we could just do 1 and double it, but I'll just write it in, it doesn't matter. Okay, so, we need this distance. This distance over here is 40 millimeters. And over here is 40 millimeters as well. Okay, so the area we have is 40 multiplied by 10. And the y bar 2 is 30. Okay, plus 40 times 10 times 30. Okay, because they're the same. Okay, so Q total, and this is in millimeters, by the way. So Q total is,
You want to do that third, right?
it's 4.94 times 10 to the 4th millimeters cubed, okay? Remember, this is millimeters cubed because we have an area times a distance, okay? All right, so we got Q total, and remember, tau max is equal to V max times Q total over I total times T. Alright, so we got everything now. We got the total moment of inertia, we got the total, we know T is going to just be this distance, it's 12 millimeters, and we can solve for V max now. Okay. Alright, races. Okay, so we want to solve for V max, and V max is equal to tau max times I total times T all over QT, right? And tau max was given, we just found all the rest of the stuff we need. So V max is equal to 50 times 10 to the 6 PA multiplied by the total moment of inertia I gave you guys before, but I erased it. So that value is 3.65 times 10 to the negative 6 millimeters squared. Okay. And T is 0.012 meters. Okay, just this distance. And then that's all over QT, which is 4.94 times 10 to the negative 5 meters cubed. Okay, I just converted it into meters. All right, so the maximum shear force you get. Okay, you get. This is 44.3 kilonewtons. Okay, so that's the first part of the problem. Once you solve for this, now we know the maximum shear force. You're going to need that to find the transverse shear in this section, and this section. Okay. You guys got it. So now that we have that, that's good. So now let's start with section A. We want to do transverse shear in section A. Well, let me erase this. Okay, so now we want to just draw section A. So section A is just this part over here. It's up here. This is A over here. Okay, we're obviously going to have to calculate QA. And that distance, this is 30 millimeters. And also, this distance is, okay, from here to here. From here, this is half of 50 is 25, so from here to here is 25, and then from here to here is 10. So this distance over here is what? 35, exactly. Okay, so we're going to need y bar A. What is y bar A? It's this distance over here. Y bar A.
65 divided by 2, so 32 and a half.
What?
32 and a half.
32.
Yeah, 65 divided by 2.
65 divided by 2. No, it's not.
No, it's
It's
30
not.
divided by 2 plus 35.
Exactly, that's it, yeah. It's
So
35 plus half this.
Well,
Yeah,
50.
so it's 50 millimeters, yeah. Okay, so YA is 50 millimeters. Alright, so we're going to have to calculate Q, because remember, tau is equal to V max QA, I'll call this QA, over I total. The moment of inertia never changes. It's a total moment of inertia always. So the only thing that's changing is this and T. Well, T in this case is the same, so that doesn't even change. So T A. Okay, T in section A is still 12 millimeters. Okay, so QA is equal to AA times Y bar A. Okay, so this is equal to 30 multiplied by 12 multiplied by 50. Okay, so QA, and this is in millimeters. Okay, so QA is 1.8 times 10 to the 4th millimeters cubed. Okay? Alright, so we have everything. So we want to find the transverse shear in section A. So we can just use this formula, BQ over IT. This is the only thing that changed, so we substitute everything else. We can get this transverse shear in that section. It's pretty simple. Okay, so we gotta erase this. So tau A is equal to 44.3 times 10 to the third newtons. Remember, it's 44.3 kilonewtons times, we just did the transverse shear in section A. This is 1.8 times 10 to the negative fifth meters cubed. Okay, I converted it to meters again. Before I left it in millimeters. All over the total moment of inertia, which is 3.65 times 10 to the negative 6 meters to the fourth, multiplied by, oh, the thickness is still 12, so it's 0.012 meters. Okay, so tau A is equal to 18.21 MPa. Okay, so that's the first answer, because I want to know the transverse shear in section A, and then B, and then C. Okay, so that wasn't that tough. Okay, let's find the transverse shear in section B. Okay, so now we want to know the transverse shear in this section. So for Q, you just draw that. You don't care what else is happening in the rest of the beam. You just want to know what's happening in that section. So you only draw that section. Okay. So we have this little piece over here. This is section B over here. So we're interested in this Q. Okay. And what is T in this case? T changes. You guys know?
T would be 92.
Huh?
T would be 92.
No. This is T. T is just this distance over here. It's
What?
just 10.
Why is it not the length along the axis?
No, this is B over here. B is this, it's this point over here. So we're interested in just this. This is C over here.
Right.
When you calculate for C, you're gonna have that total length, but it's still only 12 T. T is just the thickness of the member.
Okay.
Okay. Alright, so T in this case is 10. Okay. Alright, so this distance over here is 25. 25 millimeters, and this distance over here is 10. Those are the only distances you need, is 10 millimeters. Okay, and now, so erase this, and this distance over here is 40. 40 millimeters. Okay. So now we want to calculate the transverse shear in section B. So now our formula is tau B is equal to B max QB. The total moment of inertia stays the same, and the thickness now is TB. Okay. All right, and we discussed before TB is equal to 10 millimeters. It's just this section over here. For this. Okay. Alright, so let's calculate Q because Q changes. Okay, QB is equal to, alright, so now we're going to need YB. So Y bar B is equal to what? You have 25 plus half 10. Half of 10, so you have 30 millimeters. Okay? So this is equal to AB times Y bar B. So QB is equal to the area, which is 40 times 10 multiplied by 30. Okay. Okay, so QB is equal to 1.2 times 10 to the negative fifth. Okay, I just converted it right away. Meters cubed. Okay, this is all in millimeters. So you get 1.2 times 10 to the fourth millimeters cubed. So change it into meters. This is what you get. Okay. So now we can directly plug in to find the transverse shear at B. So tau B is equal to 44.3 times 10 to the third newtons multiplied by QB, which is 1.2 times 10 to the negative fifth meters cubed, all over. The total moment of inertia again is 3.65 times 10 to the negative 6 meters to the fourth, multiplied by the distance right now, tau, the thickness in part B is just this, so it's 10 millimeters. So it's 0.010 meters, okay? You don't need to add 0. Okay, so tau B is equal to 14.6 MPa. And then finally, we're going to have to find the transverse shear in section C. Okay. So now, let me ask you guys, before I even draw it, what do you think T is in this case?
12.
It's just going to be 12. Yeah, it's the same. Okay. Alright, so let me erase this. Okay, so you want to find tau B, tau C. So this is tau C is equal to QC, and then now T, the thickness changes to C. Okay, so let's draw that. And this is important because something like this is going to show up on your exam if he asks anything. So, okay. Wait, what am I drawing? I'm drawing it on the neutral axis. That's not right. Okay, the neutral axis is over here. Okay, so now remember, this distance over here, from here to here, is TC. Okay, so TC, let me draw the distances in. Okay, so this is 40 millimeters, this is 12 millimeters, and this is 40 millimeters. Okay, and we need these distances. This distance, and this distance. Okay, this is 30 millimeters, this is 10 millimeters, and this is 25 millimeters. Okay, it's just half of it. Okay, so this is section C over here, right? So we're gonna have to find QC. So QC is gonna change. So this is QC, right? But in order to break this up, in order to find QC, we're gonna have to break this up. And it doesn't matter how you break it up, it really doesn't matter. You could break it up like this, or you could break it up like this. It doesn't really matter. It really doesn't matter. Let's just, let's make it simple. Let's make our lives simple. Let's just break it up like this, right? So you have two sections. So I'll call this 1, and this is 2, okay? So you want QC. So QC is equal to Q1 plus Q2, okay? So QC is equal to, we need this distance. This is y bar 1, and then you need y bar 2. Whoops. Okay, so what's y bar 1?
30.
It's 30, exactly. It's 30 millimeters. What's y bar 2? 35, 50, yeah, 50, you're right, exactly. 50 millimeters. Okay, that's good. All right, so you guys are understanding this because a lot of people just don't even know what's going on. Okay, so you guys know. Okay, so this is A1 y bar 1 plus A2 y bar 2. Okay, so QC is equal to this distance now, you're right, is 92. 40 plus 12 plus 40 is 92. So it's 92, I'm finding the area right now, multiplied by 10. And then y bar 1 is 30. And this is plus A2, which is 30 times 12 times 50. Okay, good. So QC is equal to, I'll just give it to you again. This is in millimeters, but I'm going to convert it right into meters. QC is 4.56 times 10 to the negative 5th meters cubed. Okay, so we found QC. We know TC is just 12. Okay, so let's find the transverse shear in section C. Okay, I'm going to erase it. Okay, so tau C is equal to, again, Vmax never changes. It's 44.3 times 10 to the third newtons multiplied by QC, which we just found to be 4.56 times 10 to the negative 5th meters cubed, all over the total moment of inertia, which is 3.65 times 10 to the negative 6 meters to the fourth, multiplied by t, in this case is 12. Okay, so it's 0.012 meters. Okay, so tau C, transverse shear at C is equal to 46.1 MPa. All right, so get comfortable with this because you could see this on the exam, something like this. This would be a good exam problem. This is what I would put on the exam if I.
Not all three though, right? Because that would take forever.
Yeah, well, I'd put like maybe 2. This isn't a long problem. I would just you get an hour and 20 minutes, so you could do this. I mean, it's not that bad. You find the total moment of inertia, you find V. But people wouldn't even know what to do. Like you have to find V first in order to solve for the transverse shear first, shear force, in order to solve for the transverse shear in these sections. So that would be like the most points, something like that. Okay. All right. So I have one more problem to do. It should take really quick, and then I'll pass around the sheet. And for you guys who stayed, you'll get some points. Because everyone decided to leave after the competency. And not just that, they're missing something really important. So, any questions on this? Or erase it?
What does Vmax mean again?
Okay, what was Vmax?
Yeah.
Okay.
I'm not going to solve it, I get that, but what is it?
It's a maximum shear force, the maximum shear force that you need to get this, the maximum transverse shear.
Right.
You need that in order to solve for the transverse shear in these sections. Because remember, this formula is VQ over IT. So you need V in order to solve for each one. And they don't give it to you. But V is a transverse shear. It's a transverse shear force.
Right, so if that's a cross section, the shear force V would be vertical?
Yeah, it's vertical.
Okay.
Yeah. I don't know. You seem to think this. Okay. 7.1. Alright, so this problem's really simple. Alright, this is a transformation of stresses. They give you this 2D stress over here. They give you, it's in compression. So sigma y is equal to 10 KSI. So it's in compression over here. 10 KSI. Okay, and then they give you the shear stress as 15 KSI. Okay, and this direction is negative, even though you don't really need to know that for this problem, but you should know that this is positive. Tau is positive in this direction, and if it's in this direction, it's negative. Likewise, what's wrong with this? Okay, so in this case, tau is negative. It's 15 KSI. Okay. And obviously, if sigma y was outwards, it's in tension, right? This is sigma y, this is tau xy, and this is sigma x. This is sigma x, sigma y, tau xy. Okay. This is like a fully loaded 2D shape. Okay. So I know you're gonna get like a homework problem like that, where they give you, in this problem, what they want you to find, the stresses in this section. They give you this angle, this is 60 degrees, and they want to know the stresses, the normal stress and the shear stress in this section over here. Okay, so they want to know the normal and shear stress in this section. So you're obviously going to have to cut it over there. Okay, so you guys are going to learn half of this Morse circle. I don't know if you already went into Morse circle.
No, not yet.
You did? No, he didn't.
He did this stuff already. I don't know.
The transformation of stresses, yeah, but next is Morse circle. You'll probably learn it this week. Okay, so they asked for the stresses in this part over here, right? So we're gonna have to draw a stress, you could call it a stress diagram. I don't know what they call it. I'll just call it a stress diagram. So stress, okay. So we want to know the stresses in this section. Maybe I should draw it over here so we can see it better. All right. Okay, and we also need the corresponding areas because we're going to have to do a force balance. Okay, and you've seen this before. I think I showed you this maybe the first recitation. Okay, so you need the stresses in the area. So you want to draw the triangle, right? This is a triangle. They give you this angle at 60. So what's this angle?
30.
It's 30, exactly. This is 30. Okay. All right, so let's draw the stresses, okay? You're just copying this onto this triangle, right? So you have this shear stress, tau xy. It's 15 KSI. And then you have this sigma y, 10 KSI. And then you just have, now you have stresses in this section, okay? So you have a normal, whoops, sorry, that was loud. So you have a normal stress, and you also have shear stress. Okay, so this is what we're looking for, okay? Sigma and tau. We want to find sigma and tau based on this. So what do you guys know? Well, let me draw the areas first, and then I'll ask you this question. Okay, so this is the area we're interested in. So we'll call that A. This is 30 degrees. So what's this area over here? Just from trig. It's no trig.
A sine 30.
This one? This is A sine 30.
Cosine
Yeah, A cosine 30. Yeah, A cosine 30, and this is A sine 30. Okay. All right. So now this is going to be my question because a lot of people never do this from statics, and I mean this is really important. Okay. So now we want to know. We want to do a force balance in the x and y direction, right? You could do a force balance along this direction, but I chose to do it along the x and y direction. Just to make your life a little more complicated. Okay, so no, but it's really important to know. Okay, so we need to know the angle. They give you this angle over here, it's 30. So we need to know this angle and this angle over here. How are we going to find that angle? Let's think about this. If this was flat, sigma would be straight up, right? If we're inclining it 30 degrees,
So sigma.
you see that? 30 degrees, we just inclined it 30 degrees.
So it's 90.
So this over here, whoops, this angle over here is 30 degrees. You guys agree? You've seen this in physics, whether you know it or not. This angle is 30 degrees, and that means this angle over here is also 30 degrees. Do you guys know? Do you guys see what I'm talking about? Okay. What I'm saying is, let's think of tau being like just horizontal, and then sigma being straight up. Okay? So now we're tilting it 30 degrees. So you can see, originally it starts over here, and then when you tilt it, it's going to end up over here. So now sigma's over here. So this angle's 30, and this is going like this. So this is going to be decline now. So now tau's like this. So this angle has to be 30 as well. You guys follow? Okay. Because you need that to do the force balance. Okay, so that's good. We got everything, right? And so we want to sum the forces in the x and y direction. We're going to have two equations with two unknowns, 1 and 2, and then you can solve. Okay. You guys follow what's going on? It's just statics. Okay. So let's sum the forces in the y direction first, taking upwards to be positive. What do you guys got? Let's see if you can do this force balance.
So sigma cosine 30 is equal to 10 psi?
Sigma cosine of 30. That's right. But remember, this is a stress, so we have to make it a force. So we multiply it by the corresponding area. Okay. So that's right. No, you're right. Okay, this is the stress, and to make it a force, you have to multiply by its area, A. Okay. So that's good. What else do you guys got?
And then 10 ksi times a cosine 30?
Okay, so 10 KSI times A cosine of 30, that's correct. That's good. You keep going.
Sorry.
You got two more forces. You did this one and this one. This is in the negative direction, and this one also is in the negative direction. Do you see that? The component of tau. So you have minus
15.
tau times A, the area is A, and this is the sine of 30. Okay, so it's actually, if you want to write it how you wrote it, let me rewrite this. So it's actually, this is not to confuse you guys, so it's tau times the sine of 30 multiplied by its corresponding area, which is A. Okay, and then we have one more. So we have also minus 15 and multiplied by the corresponding area, which is A sine 30 is equal to 0. Okay, we got everything. Minus, minus. This is plus. I don't know why I said minus. This is going upward, so it's plus. Okay. All right. So this is one equation. We have two unknowns, right? So we're going to have to sum the forces in the y direction to get another equation, and then you can just do algebra and solve. You guys know what it is. Okay, so let me write the other equation right over here.
You can do it underneath it.
Yeah, good idea. All right, so summing the forces in the x direction, taking the right to be positive. So you have minus sigma sine of 30, right? That's this component over here. Multiplied by its corresponding area, which is just A. And then you have minus tau times the cosine of 30. That's this component of the force, multiplied by its corresponding area. So minus tau cosine of 30 multiplied by its corresponding area, which is just A. And then you also have this force, this is in the x direction. So you have plus 15 times its corresponding area, which is A cosine of 30. And then finally, that's it. Okay, this is equal to 0. You're right. There's no other forces in the x direction. So we got 1, 2, 3. Yeah, that's right. Okay, good. So you have, this is equation 1, equation 2, right? You guys know how to solve. You have 2 equations, 2 unknowns. You move this to the other side, you solve for one of these, you can move this also, and then you isolate sigma, stick it into this equation over here, and you can solve. I'll write it out, just so you guys can have the answer. Right? But the most important part is this force balance. If you understand this, you're golden. That's the most important part. Okay? Any questions?
We would be given the area, right?
Yeah, you'll be.
You don't need the
there.
area.
But you don't need it. Yeah, you
They
don't
all
need
cancel
it.
out.
Because it'll drop out. Notice how each term has a. You know, so if it's all equal to 0, so they'll drop out.
Well, it'll always be in like a square shape.
Yeah, they're always going to give you the square shape, and they're going to ask for the stresses in some. They can give you
Some part.
any angle, yeah, and you're going to have to find the stresses in that section.
But
Okay.
there's no chance that he'll get like a rectangular version or will it be square?
No, it's always going to be a square. Yeah. I've never seen that. I mean, he could, but then he's going to have to give you the area. Then he's going to have to give you the area. The reason why you don't need it is because it drops out. Okay. And, okay, so let me give you those equations. Alright, so after you do the algebra, did you guys take linear algebra? Or no? So you don't know how to use matrices, right?
We do.
Oh, you do? Okay. So I'm just, and I was lazy and I didn't want to stick one in terms of the other, so I just used the matrix and just plugged it in my calculator. So it's 0.866 minus 0.5, 0.5. This is matrix A, by the way. 0.866. Okay. And your unknowns go over here. This is sigma, tau. You don't have to do this. You could just stick one in terms of the other. Okay? This is just another way of solving it. And this is 1.16. It's negative. And this is 12.99. Okay? So if you wanted to find tau, sigma and tau, you just do, I'll call this A, B, and this is matrix C. So if you want to find sigma and tau, so sigma tau is equal to A, which is 0.866 minus 0.5, 0.866. You take the inverse of that and multiply it by matrix C, which is minus 1.16, and this is 12.99. You guys know how to do this probably. You've seen it somewhere. Okay, so sigma is equal to, and tau is equal to 5.49 KSI, and this is equal to 11.83 KSI. Alright, that's it. Alright, let me pass around the paper for you guys who stayed.